Alright, this is from www.survival ebooks. It's Subcourse 0 OD 1007 Edition A, U.S. Army Ordnance Center and School Wheel Vehicle Steering Systems. This U.S. Army Light Vehicle Wheel Vehicle Mechanics 63B Skill Level 3 Course Wheel Vehicle Steering System Subcourse number 0 or OD 107 is 5 credit hours. Lesson 1, Fundamental of the Steering System. Describe the fundamentals of the steering system. Give information, construction, operation, inspection, mechanical steering linkage principle, steering gear geometry. Lesson 2, Fundamental of the power steering. Describe the fundamental of power steering. Conditions. Give the information, principle, operation, construction, inspection, power steering systems. Alright, Section 1, Table, Title, Table, Contents, Administrative Instructions, Grading, Certification, Instruction, Introduction, Wheel Steering Systems, and then Fundamental Steering System Learning Event. Describe 1, describe principle, steering, construction, operation, mechanical steering, gears, and linkage. Learning 2, describe the principles of wheeling alignment. Learning 3, event, describe inspection procedure, mechanical steering. Lesson 2, Fundamentals, Power Steering. Describe the learning event 1, describe the construction operation power steering system. Learning 2, event 2, describe inspection troubleshooting procedure for power steering system. And then, alright, so introduction wheel vehicle steering systems. The wheel vehicle is not much a unit that cannot be steered with the glide, with the act of the guiding of the vehicle is called steering. The wheel vehicle is to steer by the aiming, the pointing of the wheel with the direction we want the vehicle to go. Drive of the car or truck guides with the turning of the steering wheel with the steering system. Trucks consist of lever, links, rods, and gearboxes, sometimes hydraulic systems. The decision of the driver steering effort. The steering system is critical, important to safety operation for the vehicle with no looseness between the steering wheel and the front wheels of the driver to keep the control over the direction of the wheels point with the wheels must end with the road current at a correct angle to good traction motor prevent unnecessary tire wear. Also, the driver should be able to hold the wheel straight with head position, change them in the right or left with little effort. For you student that studies steering, introduces many new words, parts, ideas, theories. The story includes the math, physics, hydraulics. So this subcourse provides you throughout the understanding of the design, construction, operation, maintenance, the steering system, math, the physics, hydraulics are covered right in the next text where they will apply. When you see the new word, new part, new idea, new theory, be sure you know what it means, how it works, and what it works before you continue. Alright, lesson 1, fundamental steering system. Describe the fundamental steering system. Give the information, construction, operation, mechanical steering, gears, steering, linkage, principles, steering, geometry. Reference TN 9 8000. Learning event 1. Describe the principal steering, construction, operation with the mechanical steering, gears, and linkage. One of the most interesting features of the wheel vehicle is the steering with the system. The system consists of all the parts necessary to make the front wheels turn in the direction we wish to go. The parts include the steering wheel, gearbox, all linkages, levers needed to control the front wheel. Steering systems are carefully designed so the driver can, without too much effort, keep the vehicle going straight and ahead and turning it into the right or left. The driver must be able to easily overcome the tendency for the front wheels to go to the right or left, the result of striking holes in the road, rocks, stumps, or other obstructions try to stop the vehicle, which strikes them while the other front wheel tire keeps rolling, what causes the vehicle to turn the direction of the obstruction. This is called road shock. Road shock tries to jerk the steering wheel out of the driver's hand without hitting the obstruction with the difficult to control of the vehicle. The steering system is designed to reduce shock caused by striking objects. Another feature of the steering system is the front wheel alignment, which is referred to as steering geometry. Free front wheel alignment can be defined as proper position front of the wheels to make them easy to turn right or left to reduce the tendency for the tire to scuff the wheel unevenly. Proper alignment reduces the tendency of the front wheels to wander, proximity makes a much easier control vehicle. Figure 1 shows Ackerman steering, center line, vehicle steering arms, rear axle, straight ahead position, center rotation, knuckle, pivot pins, or Ackerman steering left turn. Alright, your fifth wheel steering. Remember you have the toy wagon you played with in the younger days. The steer of the wagon with the holder with the wagon's wrong handle with the right or left of the axle with both front wheels turned with the tongue. Axle with a single shaft with the wheel mounted on each end of the pivot of the center so the axle could turn and change the wheels with the straight head position to the type of the steering arrangement known as fifth wheel steering. Fifth wheel steering is commonly used for the towed truck vehicle, such as the semi-trailers pulled by the tractor trucks, and the lower part of the steering pivot, the fifth wheel mounted over the center, slightly to the front of the rear axle with the tractor with the kingpin lock to hold the kingpin and pivot pin semi-trailer in a certain center of the fifth wheel. Usually the lower fifth wheel is mounted with a tractor with a two pivot shaft, with one shaft positioned crosswise to the tractor, the other lengthwise. This allows the lower fifth wheel to tip various angles of the tractor chassis, keep the bearings for the upper upper and lower halves. Fifth wheel and film contact with the trailer travel over unlevel loads. Upper part of the fifth wheel consists of the pickup plate and with the kingpin secured with the bottom front with a semi-trailer groove around the kingpin allowing so engagement with the kingpin lock. Semi-trailer connected with the tractor so become bottom of the trailer with the tire with the tractor wheel if necessary because of the truck. Trailer make turn enter the rear axle wheel assembly pivot under with the front of the trailer frame on the very sharp turn wheel on the inside of the turn will move about with the middle underneath the trailer chassis clearance here must be provided for these wheels. Alright, figure 2 shows fifth wheel steering, center line of the vehicle, steering arms, rear axle, straight ahead position, center of rotation, fifth wheel steering. Ackerman steering, the fifth wheel method of steering is not suitable to steering in a modern car with a truck with a vehicle chassis that have to be high and off the ground to provide clearance with the front wheels. Cars and trucks use different front wheel arrangement and called the Ackerman steering method. This arrangement axle is held at the right angle of the vehicle, but the frame cannot pivot. The wheels change with a straight ahead position independently. Separate pivot pins, knuckle pivots at the end of the axle. We'll discuss the Ackerman steering method during the rest of this lesson. Clarify the terms will be used with regard movements of this method. We say with the wheels pivot, we mean they are changed in relation to straight ahead position, which is making them right or left turns. We say the wheels rotate, we mean that they turn spindles on their spindles as the vehicle rolls forward or backward. Center of the steering linkage shows the steering column, the steering gear, the pitman arm, the knuckle arm, the drag link, the tie rod, the intermediate knuckle arm, and the front cross member, and the tie rod to the other knuckle arm. Alright, steering linkage. To make turn the driver car over the truck turns the steering wheel to right or left because of each front wheel has its own steering pivot. The considerable amount of linkage needed to transfer the steering of the wheel move with both wheels of the steering wheel is located at the top of the steering column. As is turned, the steering gear at the bottom of the column is operated steered linkage all over the left of the rod arms linkage. You can connect with the steering gear with the front wheels. For this is a wide variation amount of the steering linkage in different vehicles. Most vehicles with front axle suspension have steering linkage arrangement like one shown figure 3 with the linkage consists of the pitman arm spline with the output shaft of the pitman arm shaft with the steering gear drag link which links to the pitman arm with the steering knuckle arm with the left front wheel with the two steering knuckle arms, one secure with each of the front wheel spindles, the tie rod which links the two front wheels of steering arms together. Then the linkage may be arranged and the tie rod is in the front of the axle behind it. Rotary motion steering wheel causes the pitman arm shaft to move back and forth in the arc with a sum of the drag link for the move back and forth in the straight line with the drag link transmit the movement of the lifting arm to the pivot left the wheel with the spindle wheel back and forth with the steering knuckle pivot the minimum of the left wheel with the transmit with the right wheel with the tie rod. The drag link of the tie rod free is fastened with the pitman steering arms with the adjustable ball socket joint that permits swiveling action for the ball type of the studs with the screw with the pitman and left the steering arm with the housing at the end of the drag link reed with the ball socket with the coil spring with the spring sheet with the screw plug with the housing holding of the ball with the screw with the plug can be screwed in and out with the tighten, loosen the joint, lubricating fitting for the provide with each joint, shields for the hold the lubrication in and keep the dirt out. Tie rod used with the ball socket joints generally they are not adjustable spring hold with the ball in seat with the prevent slack with the ball of the tie rod of the tapered shank. Stud fits to the end of the matching tapered hole of the steering arm. The end of the ball is then threaded with the drill with the end and can be secured with the steering knuckle with the nut and the cotter key. Each tie rod is threaded with a screw on the tie rod end of the clam bolt prevents the tie rod from turning once the end of the turn once the end has been installed. One tie rod, one end of the tie rod have left hand threads, and the one other tie rod ends of the opposite end of the tie rod that have right hand threads. This is so overall length of the tie rod assembly can be adjusted along the front wheels without disconnecting either tie rod end. If the vehicle was independent front wheel suspension instead of the axle steering linkage arrangement, the difference of the two rods required so that each for the wheel raised with the lowered and effective the steering over the others. Many different linkage arrangements are even independent of the suspension. Some are quite simple with the linkage consisting of the pitman arm and the two tie rods and the steering arm. Other common arrangements are an idle arm drag link with an ease of the arrangement. The idle arm is mounted with the right frame with the rail with the bracket with the parallel to the pitman arm. The drag link connects with the pitman arm and idle arms move with the steering wheel with the cover of both arms. Just swing with the same arc with the both steering arms are linked. Two drag link separate with the tie rod, the arrangement with the drag link called with the relay rod, pitman to arm to idler rod, arm rod. Easily the length of the both the tie rods adjusting them independently when the alignment of the front wheels, the ends of the drag link with the tie rod vehicle with the independent wheel suspension usually not adjustable on below some late model cars. Tie rod ends lubricated with the life of the manufacturer do not contain lubricating fittings, either threaded with the rubber bushing as used with the idler arm to idler arm back or bracket pivot. The threaded type of the bushings contain both internal external threads. The external threads are general right-hand threads and or screwed but tighten into thread and hold with either with the idle arm in its bracket. The internal threads are generally left-hand bat-headed threads and are screwed in the thread head end of the arm of the bracket until the bottom of the thread and backed off one turn. Let's leave the idle arm free to pivot on the inner threads of the bushing. Steering gear. The steering wheel coupled with directly with the pitman arm by shaft will be very hard for the driver to steer the vehicle. Something must be used between the steering wheel and the pitman arm to drive the mechanical advantage of the steering easier. The function of the steering gear. The principle of steering gears can be demonstrated with the bolt and the nut with the following manner: with the screw with the nut with the midpoint with the threads on the bolt with the placed end of the bolt with against the flat surface, and it cannot move back and forth but can be rotated, holding the nut so that it cannot rotate. Then in turn the bolt is then turned clockwise. The nut is pulled toward the bolt's head. The bolt is turned counterclockwise. The nut will be moved away from the bolt head. Now, if we cut off the section with the nut attached to the swift to it, place it against the bolt with the so that the principle is U with the steering gear with arrangement. Turning bolt back forth will cause the nut suction swing back and forth, turning swift shaft with it. And steering gear with the part of the like of the bolt with called the worm. The worm is secured with the lower end of the shaft of the steering wheel on the opposite end of the worm and the steering wheel that turn together. The steering gear part with those like sections of the nut called the sector. The shaft is called the pitman arm shaft. Pitman arm is splined with the pitman arm shaft. The steering gear worm bolt with the sector nut section mentioned for the machine so that there's very little flash with the lash or clearance between their threads for the mid position. However, the worm is turned with the steer vehicle either the right or left of the mount with the lash increase with the mics up from the unequal wear that occurs in normal use. The vehicles are operated with the tread head position most of the time, and some of the most of the wear is in the center of the steering gear worm. It requires 2.5 turns and 3.5 turns with the steering wheel of the worm moved to the pitman arm that is entirely allowable with an arc with about 70 degrees with the pivot of the front wheels of the hard turn with the one direction, 2 with the hard turn with the opposite direction. The steering wheel had to turn farther because of the mechanical advantage gained by the worm in its sector. Most of the extra steering gears are designed that they provide mechanical advantage mid-position when wheel turn with extreme right or left so that they are said to be variable ratio. Many different kinds of steering gears are used, but they all work in about the same manner. Figure 4 shows your worm sector, steering gear, shaft gear, filler plug worm, adjusting nut sector, tapered roller bearing, and pitman arm shaft. Your worm and sector steering gear with the type of the steering gear looks like the bolt with the nut with the sector with the type of the gear instead of the nut with the teeth of the sector of the machine and arc with the curve of the so they actually look like a section of the gear. The steering wheel with the worm turn with the worm pivot the sector pitman and shaft of the sector between the arc with the 70 degrees become the top of the extreme when it's touched with the steering gear housing. Worm is assembled with the bearings and so the means provided with adjust the bearings of the control of the worm and the play with the pitman arm shaft fitted into the steering gear housing of the bearings generally with the bushing type of the rolled bearings or sometimes even the last adjusting screw is also provided with the sector can move the close or too farther away from the worm gear. Control backlash between the sector and the worm threads for the teeth. The worm and the sector steering is very simple with the construction. This makes it cheaper to build and easy to maintain. Disadvantages that a lot of friction between the sliding action between the worm and the sector gear teeth. Show the worm and the roller and the steering gear with the roller, the steering shaft of the worm and the roller bearing and the housing of the crank cross shaft. Worm and roller steering gear. The worm and roller steering gear is much more worm and sector, but the sliding friction is changed with the rolling friction, so the less of effort is required to turn the steering wheel. This may be possible. The machining sector teeth of the roller friction is reduced to even more with the mounting of the roller on the bearing shaft side of inner end of the pitman arm shaft. The worm has a housing hourglass shape smaller than the center end at the ends. For the hourglass shape makes the roller stay in the better contact with the worm and teeth and the end of the worm. It shows the cam lever, steering gear with the steering shaft, the cam housing, cross shaft, studs, lever, ball, cup, pitman, arm. Cam lever steering gear. Within cam lever steering gear with the worm is known with the cam and the inner end of the pitman arm shaft of the lever contained with the tapered stud with the stud engaged with the cam with the levers move back and forth and the cam is turned back and forth. The tapered stud with the fixed lever with the cannot rotate through the sliding friction between it and the cam there, but some of the vehicles with type of steering gear with the stud is mounted in bearings so that the rolls and cam groove threads instead of sliding. Some large trucks and cams twin lever steering gear, but there's nothing more than the cam lever gear with the two tapered studs inside of one. The studs may be fixed in the lever and they may not be mounted on bearings. Alright, so figure 7, the worm nut steering gear shows the sector steering adjusting screw, the sector gear, your ball nut, and your steering shaft, the ball returning guide clamp, ball return guides, and selector shaft. Worm and ball nut steering gear. Another form of the steering gear is called the worm and ball nut. It is in operation, really acts like the bolt nut of the nut is matched with the worm and screws up and down. The worm is turned back and forth. The steering gears are also called the recirculating ball type. Both of the nut and worm have been round-shaped threads with a steel ball fit in. The balls active with the bearing to reduce the friction between the worm and the nut. The ball is guided on one side of the nut, allow the worm to recirculate with the worm turn, screw the nut back and forth from the worm. The nut on the teeth of one side of the mesh with the section with the turn the pitman arm shaft back and forth as the nut is moved back and forth. As with all rest of the steering gears described in play with the worm and backlash between the nut and sector teeth are adjustable. So this shows your rack and pinion steering gear with the steering shaft and pinion in the rack. The rack and pinion type. In the rack pinion steering shaft of the steering gear shaft has the pinion gear end of the mesh with the long rack. The rack is connected to the steering arm with the tie rods with adjustable to maintain proper toe angle. The steering toe wheel and the rotate with the pinion gear end over the gear steering shaft. Rotate with the pinion move of the rack left and right to operate the steering linkage. Rack pinion gears are used in small passenger vehicles. A high degree of the precision steering is required. Their use on large vehicles is limited. Four-wheel driving and steering. Four-wheel drive. The construction with all four-wheel vehicle drive is used mainly with the military vehicles. Universal joint U with the end of the axle shaft with the wheels of the free pivot at the end of the axle with the being driven through the axle, the end of the axle housing, and those with the universal joint have the vertical trunnion pinion if acting with the steering knuckle pivot. The wheels mounted on the steering knuckles attached with the trunnion pivots that are free turn around the pivots at the same time the driven through universal joints inner axle shaft with the steering knuckle arms are mounted on the steering knuckles so that the wheels can be turned around with the trunnion steel steering pivots of the steering linkage. Four-wheel steering. All four wheels are steered with the steering wheel by connecting the steering linkage with these wheels with the pitman arm of the rear wheels are connected by the knuckle arms of the tie rod because of the rear wheels must be turned in the opposite direction. Front wheels to travel in the same area arcs around the center of the rotation drag link for the front of the rear wheel steering linkage cannot be connected directly to the steering gear arm. The drag link of the front wheels move forward while the drag link and the rear wheels move rearward, vice versa. To accomplish this, intermediate steering gear arm is pivoted to the frame side member near the middle of the vehicle. The drag links are connected to the opposite end of the arm as turned by direct connection of the pinion arm. This by means of the intermediate link, the front rear drag links are moved in opposite directions. Alright, learning event 2. Describe the principle of the wheel alignment. It's not enough to merely place with the front wheels and spindle, steering with the knuckle, with the roll, with the drive, with the can pivot to the right or left, with the wheels with the point of the line just right with the vehicle is to the steer proper. The wheel alignment, the steering gear arm, and position with the front wheels. Best control force of gravity, function, friction, momentum, centrifugal forces. All forces tend to make the steering difficult, perfectly arranged. Aligned wheels do not wander, weave, or shimmy the scuff of the tires, yet they are easily pivoted without making a turn. Addition with the front wheels straighten out the driver to relieve the steering wheel after turning the corner. To do this, the front wheel to the pivot, the pin for the position, straight up and down, straight ahead with the tilt of various angles with the 5 different angles that conclude with the alignment. The front wheels with the caster, camber, kingpin, inclination, toe in and toe out. Definitions of the angle of their effects of the given in the following paragraphs. The caster angle with the spindle with the positive and the negative spindle, the CL with the vertical line with the center line. Caster is measured in the degree front and steering knuckle, front spring, axle, I-beam. Positive caster, solid axle suspension, true vertical caster, angle, interline spindle with spindle support with wheel contact, pin point, lead point, independent suspension, positive center angle. Caster on a bicycle fork tilted backward to top of the straight line, drawn with the down from the front wheel pivot. The kingpin would strike with the ground and head of the point with the tire contact with the road. Wheel mounted in this fashion should said to have positive caster and just caster if the top kingpin is tilted forward in a straight line drawn through the behind the point with the tire contact with the ground. The wheel is said to have the negative caster. One of the vehicle axle suspension casters obtained with the axle being in the mount at the top of the steering knuckle with the kingpin is tilted to the rear. An independent suspension upper pivot pin is set with the rear with the lower pivot pin with the caster angle is measured in degrees. Angle is shown in drawing one of the straight up and down, drawing with the second line through the center of the kingpin with the pivot pin with the caster angle. The angle formed to add the point of the width 2 line cross the view of the side of the vehicle. From above the description caster, we can say that the caster is positive caster of the backward tilt with the kingpin with the top. Negative caster of the reverse of the kingpin tilted forward at the top. Positive caster cover the vehicle to steer in the direction of the tends to go with the cover of the automatic steering effect. For instance, if the forward momentum of the vehicle tends to keep the wheel with a positive caster in the straight ahead position. After rounding the turn of the cover of the wheel, the return of the straight ahead position. If the driver releases the steering wheel, the automatic steering effect is also called self-righting action, self-centering action. Automatic steering effort of the caster be shown with a picture of the bicycle, except for the mount of the caster wheels pushed forward. Resist the movements pulled pulls back with the point with which it contacts the road. Since the kingpin is pointed in the front of the tire, contact while pulling back tends to keep the straight ahead position. Other forces beside the forward momentum react with the caster so that the automatic steering is not always perfectly straight ahead. Any force of the pushing on the side of the vehicle tends to pivot the wheels in the direction of force for the reason of the pass, and positive caster tends to cause the vehicle to steer down off the crown road in the direction of the crosswind. Some of the passengers are designed to have negative casters so that they just opposite will happen. This will tend to steer up on crown road and against into the crosswind. Figure 10 shows camber X, and wheels further apart in the top, solid axle spindle assembly, solid axle suspension. Independent suspension shows the long short suspension arm center of the car of the upper ball joint, vertical positive chamber, camber and spindle. Camber. The camber angle is determined the viewing of the wheels of the front, and if the wheels are tilted out of the top of the positive of the camber, if they are tilted with the negative camber, the camber angle is measured with the degree with the shown with the drawn with the line with the center with the wheel with the drawn with the second line straight up, down with the cross if the first with the camber is down, obtained with the heavy of the wheel spindle point downward at the outer end. Originally, roads were built with a high crowns, that is, where a high and middle slope downward and to the sides, so the large amount of positive of the wheel camber was needed to so the tire would not contact road squarely. If the tire does not get set squarely on the road, it will wear on the one side, will not go to the good grip of the positive steering control. Modern roads, however, the more made flat with a vertical crown, very little camber is needed for the purpose of modern vehicles. Some camber is generally desirable even with flat roads because it moves the point of the contact between the tire and the road directly under the closer of the steering knuckle pivot. If this makes the wheel easier to pivot and reduce the amount of the road shock that's sent with the vehicle with the suspension steering linkage. When the wheel hits the bump, it also plays with the most load on the large inner wheel bearing. The amount of the camber must be carefully considered when designing a wheel to avoid some of the bad effects of the roll over the tire and by hand. Soon for the learner who did not have the turn of the tire in order to turn a corner, all you had to do was tilt the camber of the tire on the one side is rolled around the corner like a cone, and not describe the wheels of the vehicle with a cone effect for the positive camber tire to pivot the wheels out of the vehicle. Alright, figure 11 shows the kingpin inclination, steering, knuckle, spindle, ground level, the kingpin inclination, anchored in degrees, vertical line, thrust, bearing, spring seat, center line with the kingpin. Your kingpin inclination, in addition to the caster tilt of the kingpin, is also tilted atward. The top of the inward tilt is called the kingpin inclination. This is determined by the viewing of the kingpin pivot pins from the front, but the kingpin inclination is another alignment factor that is measured in degrees and can be shown by the drawing in a two line with the cross of the form of the angle of the one line pass with the center of the pivot point of the kingpin, other line is short, straight up and down. Notice for the kingpin is tilted the opposite direction from the camber wheel. Proper kingpin inclination reduces the amount of the camber needed to play for the point of the tire contact under the steering with the knuckle pivot of the front wheel to align with the properly lines drawn through the center of the camber wheel. The kingpin should hit the ground close to where the tire contact with the ground. Combination of the kingpin inclination and wheel camber angle is known as the included angle. Figure 12 shows toe in, shows the front of the spring seat with the rod adjusting sleeve with the axle and beam, and the center of the line with the tie rod adjusting sleeve, tie rod, independent suspension. Solid axle suspension, independent suspension. Toe in. Your front vehicle wheels roll perfectly straight down with the road. Elsewhere with the tires scuff, the slip of the wave, wearing the tread rapidly with the vehicle that moves ahead. Wheels resist movement that hold back in the spindles. This force is +1 with the cone effect with the cambered wheels causes the wheels to try to pivot outward. This is left with the wheel, while the wheels tire to pivot the left and the right wheel. Is the right with the right wheel be able to pivot to some of the extent they cover the steering neck with the right end, but they have slight amount of the clearance permit easy steering of the offset with the wheels aligned with a slightly amount of the toe, and the toe and wheels are close together at the front of the rear of the toe, and is measured with an inch of the mount. It's found with the measuring distance between the front wheels first at the front outer edge of the tire, then at the rear out of the edge of the amount of the toe, and this difference of the two measurements which acts usually between 1/32 of an inch and 1/8 of an inch if the wheels are closer together rear of the front, but they are said to be towed out. The amount of toe in can be adjusted shortening and lengthening with adjusting of the tie rod. Ideally, toe in measured with the vehicle standing still should be exactly equal to the amount of the wheels pivoted outward with the vehicle runs at a cruising speed. The wheels will roll perfectly straight ahead with the cruising speed with no side slippage. Your toe out. Side slippage with the tires must also be considered with the turning of the corner with the 2-center of the positive steering control pivot to prevent excessive tire wear. Each of the wheels will be at 90-degree angle with the center of the rotation roll. Easily not scuff the tread of the tire. No problem with the 4th or 5th wheel. Steering with the proper pivoting of the axle assembly moves the front of the wheel at the outer edge of the turn radius ahead of the inner wheel with a 90-degree angle is obtained with the Ackerman steering. However, the wheels are moved and must toe out on a turn. With Ackerman steering with the turning of the corner with one straight line cannot be extended with the center of the both of the front wheels instead of the two lines must be extended with a different angle in order to pass through the center of the wheels of both of the wheel with a 90-degree angle. Center of the rotation inner wheel of the pivot that must be more than the outer wheel of the exit. Difference amount of the wheel of the pivot, the value of the angle formed with the line with extend with the center of the rotation with the center of the front wheels. For instance, the line with a 3-degree angle with the inner wheel must pivot 3 degree more than the outer wheel. Also, the size of the circle of the front wheel of the travel to over the knee with the toe out of the outside of the wheel of the traveling large circle within the inside of the wheel with the inner order of the travel. The small circle of the inner wheel must therefore pivot the more than the outer wheel. Sharper the term, the greater the amount of the toe out knee. With the knee of the wheel of the toed in with the straight ahead position of the toed out the term of the difficult design problem. The problem is made with the event of hardened in fact with the vehicle the turn to the left with the left wheel with the pivot the more with the wind and turn to the right. The right wheel should pivot the more. Let's look closely the steering linkage to see how this is done. When steering arms are set with the right angles 90-degree angle with the spindle with the toe out terms cannot be attained. Both steering arms will be pivoted the same with the number of degree of the pivot rod moved and given the distance lengthwise to the axle. For example, the left steering arm will pivot at 42-degree angle. The tie rod move the right steering arm the same of the distance pivoting it at 42-degree angles. Both steering arms move the same distance lengthwise from the axle and pivot on identical steering segments of the arc. However, the steering arms are not at right angle with the spindle. If the rod behind the axle of the steering arms are inward with the wheels that are straight ahead position, the arrangement of the wheels will then toe out with the turns of the cover of the steering arm. Do not pivot the same amount with the pivot move the amount of the lengthwise of the axle. For instance, the left spindle prevents 50-degree angle with the left with the right spindle 42-degree angles. However, both of the spindles make the same distance length with the angle lengthwise to the axle because of the steering arms are pivoted on different segments of the arc. Towing is generally spoken with a number of degrees in over 20. Then the inner wheel is turned with the outer wheel is turned 20 degrees. For instance, if the right wheel is turned 20, the left wheel turns 23 degrees on the left turn with the toe in, toe out is 3 degrees. Alright, lesson 3. Your learning event 3, describe the inspection procedure of the mechanical steering system. Introduction. Steering gear is one of the most common used for the control vehicle. If the steering operates improperly, the operator loses no time with the reporting of the problem of the faulty steering gear is a gamble of life. As wheeled vehicle mechanic is responsible for some of the maintenance of the steering. The maintenance include the troubleshooting, minor repair for the steering gears, and other maintenance function with the responsible for the inspection, overall condition of the steering gear, probably with the most important maintenance of all of the common steering problems. Steering system, like all mechanical parts, develop problems. Some of these problems are unwanted factors affecting the steering. With example, the factors that are wandering, shimmering, hard steering with the wheel. Vehicle mechanics, you must know, locate the cover of the problem. All the steering problems are covered with the steering gear. Hard steering cover the operator have the trouble of turning the wheel with the cover the operator to fight, and the wheel with to keep the travel straight with it down the road. They cover the lack of lubrication, bent parts, improper adjustment, loose steering cover the steering parts with worn, broken out. With the adjustment, the driver must turn with the excessively steer of the vehicle. Warning: wandering. The vehicle wanders over the road. The vehicle should travel straight down the lever road with little or no guidance by the operator. If the vehicle wanders, the operator must continue turn the steering wheel to keep the vehicle traveling straight. Shimmy means the front wheels moving in and out with the vibrate in certain speed with the different noticeable steering wheel. Shimmy is bad with enough. The very dangerous because its force breaks some of the steering parts. Shimmy may be caused by the wheels and tires that are out of the balance and between bent wheels as well. With the other cases, shimmy will be worse if the steering parts are worn out in adjustment. Wheel tramp means the wheels are bouncing up and down with this also with the noticeable steering wheel, the vibration wheels of the shimmy tire with the turning around the steel wheel back and forth. Wheel tramp, like shimmy, is also called the wheels and tires are out of the balance. However, the out of balance portion is equal to the wheel of the tire. For this causes the wheel to move straight up and down rather than sideways in the shimmy. Wheels are tramp, likely shimmy will be worse than the vehicle if some of the parts are loose and working improperly adjusted. Vehicle pulls to one side. This may cause that over the mechanical steering gear does not make cause the malfunction. This is caused by the range of low tire pressure on one side of the vehicle to the bent frame. The electrical steering. The mismatch of the steering does not act at the same time all the time. For example, vehicle will put on the right for a while and start pulling to the left. Then the vehicle pulls to one side where the brakes are applied. And the vehicle also consider the erratic steering. One cause of the erratic steering is the loaded moves about. The two moves the less load on one portion of the body, especially of the rear. Rough steering. The steering wheel does not turn smoothly. This causes the damage to the component of the steering gear. Steering line goods damaged steering gear. Components are pitted, worn, helical cam, 2.5-ton roller, or lever pins, loose tin pitted nuts. Supporter bearings could also cause the problem quickly. Isolate trouble to first disconnect the steering gear for the rest of the steering mechanism. Turn the steering wheel. If the rust is still there, trouble to extend the steering gear. Or your drive. Vehicle when turned in either direction tries to turn more rapidly with the operator intent with the cover the bent, loose, broken parts. Especially true with the steering gear assembly is loose on the frame. Wandering drive the both of the caused by loose steering parts and several malfunctions. Same system. For example, hard steering with wandering have the same system. Operating must fight the steering wheel. Good troubleshooter always make the complete inspection with the component before removing and replacing any parts. The steering gear inspection description: steering gear 1/4 inch ton truck M151. The steering gear is assembled of worm roller type. Of the roller has two teeth of the mesh of the worm, and is usually called the two or double tooth roller. Steering gear is mounted on the body frame left side of the rail. Steering column and support with a bracket attached for the instrument panel. Steering gear, the worm gear is pressed on the steering shaft. Two tapered roller bearings support to prevent endwise movement of the thrust of the worm and end shaft. The steel trunnion pinion attached to the top of the roller selector shaft with the selector shift is mounted with the bushing type bearings pressed into the steering gear housing. Adjusting screw edge gauge and selector shaft is threaded into the cover to control the selector shaft end plate, as well as the lash movement between the teeth of the worm and the roller. Adjusting the worm thrust bearing is made with the install of the remove of the gasket of various thicknesses between the gear housing and housing cap. A bolt type bearing pressed into the steering columns with tube to support of the shaft as the steering wheel, and the pitman arm and the steering wheel will have fluted serration splines with serration with the being double width splines match blind splines on the sector shaft of the steering shaft to ensure correct insulation. Alright, your inspection procedure. Examine the steering column with the steering wheel to see if there are any bent with a crack damage in any blade. Look for the leaking of seals and gasket. If there are 3 oil seals in the steering gear, but they also have 2 gaskets that can leak. Even if the seals and the gaskets are not leaking, check the lube level of the steering gear housing. Check the mounting brackets and bolts of securing mounting. To do this, how to do the more than luck. Use a wrench to see if the bolts are tight. Check for too much of the free slack with the steering system. Remember that the steering gears are designed to have very little free play with the wheel for the straight ahead. This means that the steering wheel is in the center of the travel. That it should have noticeable free play. The center point is in the high point of the mid position. The steering gear is not in the high point. Some of the free play is normal. Next, road test vehicles, checking for binding, wandering, shimming while the vehicle is moving forward. Any of these malfunctions show up. They may cause the steering gear and some of the linkage. Let's suppose the notice of the binding. It will not be necessary to take the load off the steering gear with the disconnect the steering linkage from the steering, but the binding is still present with the steering wheel is turned after the linkage is disconnected. The trouble is in the steering gear. This is as far as the unit mechanic can go. There we go. The adjusting and replacing the steering gear on this vehicle is the job of the next level of maintenance. And it shows the practice test for level 1, and this page is intentionally left blank, and answers to practice exercise. And then the next page, lesson 2, fundamentals of power steering.